Welcome to Under the Microscope. This series is brought to you by the Real Scientists Nano team. Our goal is to provide a platform where scientists can communicate their work and interact with the public. With that in mind, every week we introduce you to a scientist working in the field of materials and nanoscience. Hi everyone, today we have with us Kerstin Göpfrich, who is leading the Biophysical Engineering of Life group at the Max Planck Institute for Medical Research in Heidelberg, Germany. Hi Kerstin, how are you doing?
Hi everyone, good. Thank you.
Wonderful, let's begin. Let's start with understanding how did you end up in your current research field?
So I'm currently researching synthetic cells and basically what life is and how it could be. And I think that's just a really fascinating question. So when I grew up and I had questions that I couldn't answer and that even my parents couldn't answer, then that's just intriguing, right? So my research is really truly inspired by curiosity. I'm just curious about what life actually is and how it could be. So quite fundamental.
Wow, that sounds interesting. That sounds exciting. So could you tell us where and how does your research fall in this big picture of materials or nanoscience? Where does your research fall? The synthetic cells.
Yeah, so well, I would say living materials in general are really exciting materials, right? They can do things that we struggle to do with other materials.
Right.
So actually understanding them and recreating them, I think, is a quite exciting field in material science. And at the same time, of course, if you look inside these materials, then you find all sorts of nanomachines that are operating on the nano scale. So nature is basically working on the basis of nanomachines, whereas in real life we actually use none, right? So we make things without them, and nature has been very good at using them, optimizing them, and so on. So actually building things on a nano scale is the basis of building a cell, and that's also what I do with DNA origami, trying to build on the nano scale.
Okay, it sounds so amazing. So it sounds like you have a lot of, or you have done, or you will be doing in the future also a lot of interesting research projects and experiments. If you have to pick one that is most fun or exciting, or the most you're proud of, could you pick one and explain it to us in simple words?
Yeah, so of course I hope that the really exciting ones are yet to come up, right? With my group now. By the way, I'm also looking for students if anyone is interested out there. But generally, so what I found really fascinating is that we actually managed to achieve to divide synthetic cells or lipid-based compartments according to very simple physical principles. So if you think about life, of course, one of the first features that come to mind is division. It's actually taking a living system apart and reproducing it. And so we managed very recently. It's actually not published yet. We managed to achieve to divide these synthetic cells. But at the same time, I think generally the idea to use DNA origami to build components for synthetic cells. I think generally that's a very interesting direction because it gives us, it's simply a new tool. And I mean, if we think about life, how it is on Earth, then it's just super complex and recreating functions by actually putting the pieces of the puzzle together, isolating components from cells and so on can be very hard. But I believe, really truly believe that if we have new tools and new materials like DNA origami, like microfluidics, then we can kind of take a creative shortcut. And so I think this general direction, that's probably what I'm most excited about.
Okay, well, we hope to wish you good luck with publishing the recent findings that you managed to split the cell. Is that correct?
Yeah.
And
into two, make two out of one. So
make two out of one. So we hope to read that in a publication soon to get more details about how exactly you did it. And you're right, it does sound super, super fascinating and interesting. So wonderful. Do you also teach, or is it only research focused, your position?
So at the Max Planck Institute, in principle, there is no obligation to teach. So it's a pure research institute in Germany.
Right.
However, of course, as a young scientist, it's my job is not permanent. I'm very much looking forward to getting also in the future a permanent job, which will most likely be at the university. And I really like teaching. So I actually also do teach at the University of Heidelberg from the summer semester on. I'll be teaching a new course on soft matter physics, from soft matter physics to synthetic biology. Yeah, we also have a very recently established Max Planck School here at the Institute, which is called Matter to Life. So it's very relevant also for the research that I do. Check it out if you're interested. It's an interesting program going from master's to PhD.
Wow.
And it's right in this topic of creating synthetic cells, basically. So there's actually a big push for this topic now in the scientific community. And within this program, we actually also have 10 master students in Heidelberg. And yeah, I also really like working with them.
Okay, that sounds really interesting. So, Meta to Life.
Matter to Life, Max Planck School Matter to Life is what the program is called.
Okay. All right.
Yeah, and actually beyond teaching students at university, I also actually really like communicating with high school students. So sometimes I join a classroom lesson actually via Skype, like we talk now. So basically do a virtual lab tour or show the atomic force microscope or so, and do this live in the classroom, so to say. And that's a project called Ring a Scientist, where we really try and get science into the classroom and make that accessible to teachers all around the world, basically.
Wow,
Yeah.
so you're covering from high school to PhD or postdoc, so you're trying to help them every step of the way, or educate them at every step of the way, or encourage them to join or stay in science every step of the way.
Well, that's what we have experienced, right? It's just passing it along down the generations, basically. I mean, I guess that's how we all ended up in science in some way or the other, because we've had great mentors, great support, and yeah, somehow been inspired by others.
You're right. You're absolutely right. That's so cool. That's wonderful. So, we hope that your research experience so far has been wonderful, and it will continue to be wonderful in the future as well. However, if you had 3 wishes to improve your research experience, what would you ask for? And I'm not promising anything here.
Well, so commenting on a recent experience, my wish number 1 would actually be that once a paper is published, we as authors, but also as readers of that paper, can comment it. So on the journal website, I wish there could be a commenting function. So the reason I feel so strongly about this is because this year I published a paper on a very simple method to actually make synthetic cells, or to make liposomes, to make giant unilamellar vesicles, simply via a shaking technique. Right. And I really want the scientific community, because I felt it can benefit the field, and I wanted to make a protocol which is super accessible. And so I wrote, I think, a 4-page protocol. I made even a video protocol, and I published this in ACS Synthetic Biology. And yeah, then I thought, great. But then 2 months later or so, after publication, I received an email from somebody who was trying to copy the protocol and saying, oh, I really cannot find this reagent. Can you help me? I checked on the company's website, and I realized they had changed the name of the reagent. And, now the protocol becomes difficult to reproduce, simply because it's difficult to find the reagents, the components. And it would be so easy for me to just add a comment to my own paper saying, look, this is the right thing, and maybe even put a link to the company's website. It's so easy and would be so helpful at the same time. You could also maybe comment, like the fact when I tried new conditions or so, it's not going to be a new paper, but it could be a comment to my own old paper. I cannot write an erratum every time I try something new, right? So this is simply not the point. And at the same time, I also wish other people could comment, could tell me, look, this didn't work for me. Why? Or this worked really well. I mean, share advice to other people. So a commenting function that on the website of the journal, I think would be so cool. And I mean, I know this is possible on for instance, on Archive, on some of the preprint servers.
Right.
But at the same time, not everybody is going to find it there, right? So, and maybe the paper is already out, then you can't put it on Archive anymore, right? So, just commenting on the journal website. This is really, if any editor is listening or anyone out there working for a journal, then this could be so powerful. I think.
Yeah, that sounds like a very, very interesting idea, and I will try to pass on the message to our in-house editors. All right, so that's your first wish. Okay, all right. 3 wishes you have.
Oh, 3. Wow. Well, then I guess number 2 could be generally a push for open science and sharing protocols, publishing protocols, and so on, but also opening research not just to other scientists but to the public. Like, I mean, I don't know, push for Skype, push for like really reaching out to students out there and so on. This would be a wish that, you know, we can attract a lot of good young people and really get them into science. And I guess number 3 maybe concerns the feedback culture. So at least for me, it's super important, especially as I progress in my career. At the beginning, people are very happy to give you feedback, right? In school, you get grades. You constantly receive feedback on the work that you do. You do a test, you get feedback, it's corrected and so on. But I feel like the more I progress in my own career, the more difficult it also becomes to really get honest feedback. I mean, during my PhD, I had a very good supervisor, Ulrich Kaiser, who was very open to give honest feedback all the time and, you know, correct the work that I've written, correct the papers, discuss it and so on with the entire group. It was a very open feedback culture. And at the same time, now as a group leader, I really think this peer-to-peer feedback strategy, like where, I don't know, a colleague who's also leading a group comes and sits in my group seminar and gives me honest feedback on what we could be doing better, what I could be doing better as a group leader in my new role. And an honest feedback where nobody feels, where everybody feels taken seriously somehow. That would be my 3rd wish, I guess.
Okay. Yeah, those all 3, I must say, are really, really important points, and no one has raised these so far. It's quite interesting. So this is really, and I think this is very important.
I don't like the standard science bashing. You know, actually, I like academia and I like the culture that we have. I know there are some things that could be done better, but in general, I think academia is great. So I don't want to do the general bashing, actually.
Just improve.
There are a few points where we could improve.
Okay, I hope we are working towards it, and I hope that at least the feedback culture becomes reality and becomes the new normal, so to say. And with the group leaders, young group leaders like you, when you are putting it out there, then I think that would encourage more people to give honest feedbacks to their colleagues and to just empower each other. I mean, that's what academia is all about. I mean, I feel that academia is, like, the science in general is so beautiful that it would be great to go together and be advance together.
Totally.
All right. Those 3 were all very, very good wishes, and I wish I could grant them with a yes, but I hope we are working towards it.
Maybe New Year comes and
yeah, maybe in 2020 we would be super, like, working. Everyone's giving each other feedback. Maybe there would be comment sections on the journal websites, and there would be more open science. Yeah. So speaking of the future, what are you most looking forward to in the next 3 months?
Oh, next 3 months is perfect time frame that you gave me, because I think I can be looking forward to move into my own labs and offices in the next 3 months, and I think that's super exciting. Looking forward to it, and yeah, hopefully start getting equipment, start getting everything set up. I think right now it's still a bit of a construction site, but I think I can be hopeful, or we can be hopeful, that in 3 months. Time to move.
You can probably do like before and after 3 months or 4 months when everything is set up.
Yeah, I can share pictures.
Yeah, and do time lapse of setting up the instruments. Those are always my favorite ones. These majestic instruments like
Yeah,
FM or
like
SM or anything.
it's like continuous Christmas for 3 months.
More gifts, more equipment, more lab equipment coming in. That's wonderful. Well, fingers crossed. And before we let you go, we would like to understand from you, what do you think are the big challenges or the big questions that the nanoscience community is trying to solve or trying to address, so to say? So, what are the big questions?
Yeah, I think actually there are many, and I think if you look out there and read papers, then you realize that many people are digging into really different directions that are all fascinating in some way or the other. So the grand challenge that I'm somehow fascinated by, I can only say again, is to really create a living system, to create a system that is capable of self-replication and evolution, and yeah, somehow make it a reality that we can build such systems on the nanoscale, but also on the micro scale. That would be a fruitful challenge, which I think will take me through my career.
Well, that sounds really interesting. As I said, I mean, I keep repeating at the risk of repeating myself. This sounds super fascinating. This replicating, this is so cool, wonderful. Then we wish you good luck with setting up your lab, setting up your equipment, setting up your group, and solving the big challenge of the evolution and the system's capability of self-replicating and so on and so forth. So, thank you very much, Kerstin, for speaking with us, and we are looking forward to having you on Real Sci Nano.
I'm looking forward to your comments and discussions that we'll have there.
Yeah, looking forward. Thank you for listening. To know more about us, please visit our website realscientistsnano.org and follow us on Twitter at realsci_nano.